Hi, in this video we'll examine a real-life application of Newton's second law, shown here. In this particular experiment, an object, my nephew's toy car, was put under constant velocity conditions and analyzed for its instantaneous motion changes using tracker software. These results were then compared with idealized, meaning applying the assumption of no net force, expected results, yielded from VPython. The two sets of data were then plotted together for comparison and showed that the motion of the car deviated from what was expected and thus likely had net forces acting upon it. Here are some specifications about this experiment. The system was the toy car, whose mass was about 0.068 kilograms based upon average measurements of toy cars. The surroundings were the garage floor, where the car moved along. The calibration stick for the tracker software was 4 feet in length. The average velocity of the car, found from using the motion and time data from the first 2 frames of the experiment, was found to be 0.377 meters per second. And our assumption was that there were no net forces acting upon the car. It should be noted that the x-axis I chose was horizontal with its positive direction oriented towards the right. If I had reversed the axes used, the velocity of the car would have remained the same, but the direction shown on our plot would be different. Here is the video of the motion of the car analyzed in Tracker. As you can see from the position versus time plot on the right-hand side of the screen, the velocity appears to be constant, as the slope yields a rather linear-looking line. We can then use VPython, shown here, to create an idealized set of data to compare with the data yielded from the tracker software. The VPython code yielded comparison data by first setting the net force equal to 0, and then plugging the average velocity found in Tracker into the Newton's second law statement in the code, along with the car's mass and initial position. The code can then update its position with each iteration run. Using the 2 sets of data yielded from Tracker and VPython, I then plotted a comparison, with the blue line being the idealized data and the red line being the actual data. As you can see, as more time passed, the motion of the car deviated from what was expected, indicating that net forces were acting on it, especially towards the latter part of the experiment. The predicted motion data overpredicted how the car would move. The car's velocity did not remain constant and actually decreased. One reason for this is that the car was a wind-up toy, meaning that prior to recording, I had to pull the car back to build up momentum to propel it forward. As time passed, the car gradually lost momentum, causing the car to move slower and slower, leading it to stop a second or two after filming ended. This push is considered a net force, meaning that in spite of the overlap that appears in the first part of the plot, net forces were always acting on the car. Thank you.